Hi everyone, welcome to the course of Generative AI. My name is Bapi Hamid. So guys, as of now, we have seen the LangChain, like how we can use the LangChain and all. So in this video, I'll show you one project actually. The project name is Interview Question Creator. So this project will be implementing with the help of whatever things we have learned so far, let's say LangChain, large language model, vector database, okay. Even we'll be also implementing one front-end application of this project. That means user will get one user interface and their user will upload the data and they will get the results. Okay, so these kinds of things actually will be also implementing. That means I'm going to show you the complete project structure here. That means we'll be doing modular coding here. But before that, I'll show you the notebook experiment, like how we can implement this project through the Jupyter notebook. Then I'll try to convert this Jupyter notebook to the end-to-end manner. Okay. So I think you saw the name Interview Question Creator. I think you are already getting what is the project about. Interview Question Creator means, let's say you are having one PDF documents, or let's say any kinds of documents, whether it's a docs documents, PDF documents, TXT documents, or whether it's a books. Okay. So what you have to do, you just need to upload that, let's say PDF to this application, and this application will automatically generate the questions. Okay, question as well as the answer. Okay, of the topic actually will be giving. Let's say you have uploaded one Python PDF here. So this application will generate some Python questions, interview questions, as well as the answer. Okay, and that question and answer you can use, let's say for your candidate, or let's say you are a teacher and you want to generate interview questions, or let's say exam questions. What you can do, you can use this application to generate this kinds of question and answer. So it would be very easy for you to generate this kinds of question. Otherwise you have to manually find the questions, manually, let's say, prepare the answer. So it will take time. But if you are creating these kinds of application, it will help you a lot, okay, to automate your process. Again, it seems like a simple project, but whenever you will be implementing, you will get the complexity. And this is like very interesting project because this is the first project I should be implementing after learning LangChain. Going forward, we'll be also implementing some advanced projects, like we'll be implementing medical chatbot, source code analysis. Okay, so these are the things we'll be also implementing. So instead of talking too much, guys, let's start the implementation. But before that, I will show you the, let's say, the requirements actually I need to implement this project, and I will also show you the project architecture. So guys, to implement this project, I need some requirements. Okay, I need some requirements. So here we'll be using LangChain to implement the entire, let's say, project. And why LangChain, I think you know, because LangChain having all the functionality, right? Let's say you want to integrate vector database, you want to integrate large language model. Okay, everything is available here. So that's why we'll be using the complete LangChain here. And large language model wise, we'll be using OpenAI model. OpenAI will be using GPT 3.5. Okay, this model actually will be using. Going forward, we'll be also learning how we can use open source large language model. With the help of that, I will also show you how we can create the application. Now, third, I need vector database, vector DB. So here we'll be using FAIS. Okay, so FAIS is another actually vector database. I think I haven't covered in my vector database series. So that's why I thought let's also show you this FAIS in this video, so that you will be also learning about FAIS. So FAIS has implemented by Facebook AI, and this is one of the vector database. This is the local vector database actually, local vector database. So you have to set up everything in local machine. Going forward, we'll be also using Pinecone Web 8. Okay, no need to worry. Then to implement the entire, let's say, front-end part of our application, that means we'll be creating the user interface with the help of FastAPI. FastAPI. I think you know what is FastAPI. FastAPI is a Python framework. With the help of FastAPI, we can create a user interface web application. Apart from FastAPI, we're having, let's say, Streamlit, Flask, Django, okay, Falcon. So these are the things you can also use. We'll be exploring one by one all of them. I think we saw the Flask previously. I think remember Flask. I think I showed you. We created some of the application with the help of OpenAI. We'll be also using Streamlit. Streamlit is very easy. If you are using Streamlit, you don't need to write any kinds of HTML and CSS code. So guys, yes, as of now, these are the requirements are needed. If I need it later on, I'll tell you. Okay, now let me show you the project diagram. Okay, the project, let's say, structure. That means the high level architecture. So here, first of all, user will, let me just draw it here. First of all, user will upload one PDF documents. Okay, let's say this is the PDF documents. So what I have to do, I have to extract the data. Extract docs. So why I have written docs? Because I think you already know, if I am using LangChain and if I'm, let's say, extracting any kinds of data from any kinds of PDF or any kinds of, let's say, file format, it would be considered as a documents. I think I already covered multiple time, like LangChain data loader. Even I also showed you inside vector database session. So guys, vector database session is very much required here, because inside vector database session I have explained each and everything you need to know to implement any kinds of project. Okay, how to connect the LLM, what is documents, what is chunk overlap, everything I have discussed there. So please go ahead and try to watch that let's say session first of all, then you'll be able to understand, okay, what is happening here. Because here I'm not going to explain in detail everything. We are implementing the project only, and we're using our previous concept. Okay, this is the idea. So make sure you complete that vector database series first of all. Fine. So we'll be extracting the documents from the PDF. Then we have to create a chunks. And what is chunks? I think I already told you why chunking is required, because LLM is having one kinds of input limit. Okay, but, so that's why actually we have to create a chunks. Okay, chunks. Then what we'll be doing, we'll be using one embedding model. What is embedding model? I think you already know. I already explained inside my vector database session. Embedding model will help you to generate the vector embedding. Okay, because I have to convert these chunks to the vector embedding. So this will give me something called vector embedding. Okay, vector embedding. Okay, embedding. And with this vector embedding, we'll be creating one semantic search. I already explained what is semantic search. Semantic search, because I think you know the power of vector DB. It will give you one semantic search kinds of functionality. Now what I have to do, I have to store this vector to a vector database. Vector database, because if I want to perform the semantic search operation, I have to use the vector database. Okay, I think you already know. Now guys, you can see my knowledge base has been created. So this is called actually knowledge base right now. Okay, knowledge base, because it is having the entire information about my data. Now I'll be connecting my large language model here. So let's say this is my large language model. LLM, that means that GPT 3.5. Okay, so this large language model I'll be connecting here with my vector database. Okay, and here I'll set a prompt. I'll just set a prompt here. So inside this prompt, actually I'll be writing what kinds of, let's say, task it has to perform. So here I'll be writing, you are a expert interview question creator. So what you have to do, whatever, let's say, data user will give you, you have to create a interview questions. Okay, or let's say 10 questions, 20 questions, you have to create it. Okay, this is the idea. So this kinds of prompt actually I'll pass to the large language model. So I think you already know prompt is everything. If I'm using any kinds of LLM, right? So with the help of prompt, we can achieve our task. This is the main idea. So this LLM will go to the vector database that time, and because vector database is having all the information about the PDF, and it will create, okay, it will create what? It will create you interview questions. So it will return interview questions. Interview questions. Okay, fine. Now what I told you, I'm not going to take only the interview question. I will also going to take the interview question answer as well from the large language model. So again, what I will do, whatever questions actually I'm getting, again I'll pass. Okay, again I'll pass to my large language model. Again I'll pass to my large language model, and I will tell my large language model also provide the answer, the questions you have generated. So it will give me the answer that time. So it will give me questions answer, okay, as well. So this is going to be my complete project architecture. Okay, so based on this architecture, we'll be developing the entire projects. Fine. So first of all, let's do everything in my Jupyter notebook. Then once Jupyter notebook is working fine, then I'll show you the let's say modular coding implementation as well. So for this guys, what I will do, I will open up my local folder, and here I already created one folder here, empty folder, and inside that I'm going to open up my terminal. Okay, so in case if you're using Anaconda, Git Bash, whatever terminal you are using, you can open it up. Now here I'm also going to open up my Visual Code Studio. So let me open up my Visual Code Studio. Now here the first thing what I have to do, I have to create one virtual environment. I think I already told you. You just need to create a virtual environment every time whenever you are creating different projects. So to create the virtual environment, you have to execute some of the commands. So let me share the command with you as well. So here I'm going to create a file called readme.md. So this is the markdown file. Inside that I can mention all the command, and this file will help you to render actually these kinds of masses in the GitHub. So let's say whenever you will be uploading this code to the GitHub, that time you will see that in the GitHub description, that means your project description, all the details has been written. Okay, let me show you one example. So guys, this is my GitHub profile. You can follow me here also, because here I have created lots of repository that might help you a lot. So let me show you my repository guys, one of the project actually I implemented previously. So let's say this project, okay, MLOps production ready machine learning project. So this is the project actually I created. Now if you open this project and if you go to the readme section, you will see that the complete details about my project. Okay, see the complete details about my projects, like how we can set up, what is the workflow, what are the command you have to execute. Okay, everything I have set here. So how it is rendering, it is rendering because of this readme file. You can see a readme.md file. Okay, so that's why we are getting this readme file here, because whatever things you will be writing here, it will render in the GitHub later on. Fine, this is the idea. So here some of the common command you have to execute every time. Let me show you all the command. So see guys, these are the command you have to execute. First of all, you have to create the environment. After that, you have to activate it. After that, you have to install the requirements. To install the requirements, you have to execute this command. Okay, pip install -r requirement.txt. So let's create a file here. I'll name it as requirement.txt. I'll copy and let me create the file as well. Okay, now first of all, create the environment. So copy this command and open up your terminal and execute it here. Okay, execute it here. For me, I already created the environment. What I'll do, I'll just try to activate it. But for you, you just need to create the environment. So for me, let me activate. So this is the environment I created already. Interview, you can see. Fine. Now inside interview, I have to install some of the required package. The package actually I need, I think I showed you the LangChain, OpenAI, then vector database, FastAPI. Okay, everything I have to install here. So I already listed down all the required package you need. So these are the packages guys you need. Okay, you need to install. So you can see LangChain community, LangChain code. So these are the actually dependency packages if you want to use LangChain. So you have to install it. And again, we are doing local setup guys. That's why some additional package you can see. Otherwise, what will happen actually, you might get installation issue. That's why I have added everything. Now OpenAI, PyPDF because user will upload PDF documents here. As of now, we are considering PDF documents. Fine. And TikTok is the dependency of OpenAI. Then you can see AI files, FastAPI, UVCon. So these are the dependency of FastAPI. I'll tell you whenever we'll be using these at the package, that time I'll explain. Okay, as of now, just consider these are the packages actually I need to implement the entire projects. Okay, now you can see we'll be using Fires, and to install the Fires, you have to execute this command Fires CPU, then python.env because I have to manage my secret credential. Okay, now let me save everything and you have to install it. To install it, this is the command guys I already shared. So copy the command and let's execute it here. For me, I already installed all the package. That's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, now let me clear. All right, now first thing, I'm going to create a folder here called research. Inside research, I'm going to create a notebook. I'm going to as experiment. I'm going to name it as experiment.ipynb because this is the Jupyter notebook file I want to create. Okay, that's why it's ipynb file. Now let me select the kernel. So the environment I created, this in interview. Okay, I'll select it up. Now here, first of all, let's import some library. I need the operating system. Then I also need .env. So from .env import load env. Now let me execute. So it's working fine. So I think remember I have to create a .env file here. Inside that I have to mention my OpenAI API key. So let me do it. So guys, as you can see, I have created this .env file. Inside that I mentioned my OpenAI API key. Okay, so for you have to do the same thing. Now let's load this OpenAI API key. So to load it, I'll call this load env. After that, simply I'll call the key OpenAI API key, and I'm going to use os.getEnv. Inside that I'm going to pass my key. Okay, so this will give you OpenAI API key. Let me show you. See, okay, it is printing the OpenAI API keys. Now let me comment. As of now, I don't need to print it. Fine. And now what I have to do, I have to set this OpenAI API key as an environment variable. So for this, you have to execute this line of code. So it will set this OpenAI API key as an environment variable so that OpenAI package will load, okay, from the environment itself. I think I already explained previously this part, okay, how to do it and all. Now the first thing what I have to do, guys, I have to load the data, but I don't have any data here. So let me show you some of the PDF actually I'm having. So guys, as you can see in the data folder, I'm having actually two PDF. One is like SGD PDF, one is like stats PDF. Let me show you. Let me open the PDF and let me show you. So if I go to the data folder, so this is the PDF, guys, I downloaded from the internet. So the PDF name is Sustainable Development Goals. Okay, so about this topic, actually they have written this PDF. You can see what is sustainable, let's say, development and all. They have written this particular, let's say, PDF. So this is one PDF actually will be using to generate the interview questions. Let's say you want to generate interview question based on this topic. Okay, so you can use this PDF. Not only this PDF, guys, you can use any kinds of PDF, whether it's a Python book, any kinds of physics, chemistry, English, okay, anything you can use here. It's up to you. So this is the PDF, guys, actually I'm having. Now the next PDF, let me show you. So this is the statistics PDF. So this is the topic of importance and the use of correlation in statistics. And again, you can see correlation topic has been written. So we'll be also generating some interview questions based on the statistics. Okay, that means the correlation. So these two PDF actually I just downloaded from the internet. Okay, now let's load the data here. So I'm going to open up my notebook. So to load the data, you have to, I think remember, you have to import one, let's say, function from the LangChain. So let's import it from LangChain dot documents loader. Okay, documents loader, import import PyPDF PyPDF loader. I think, yeah, this one, PyPDF loader, because it's a PDF document, right? Now let me import it. Now one thing I want to show you. So let's say if I show you my project working directory right now, so let's say pwd, this is the command to check my project working directory. Now you can see that I'm inside my resource folder. Okay, you can see I'm inside my resource folder. So because this experiment.ipynb is available inside my resource folder, but where is my data located? Data located outside of the resource folder, yes or no? Because outside of the resource folder data is available. Okay, now if I want to go back, to my root project directory, that means LangChain project, what I have to do, I have to execute one command. This command is cd dot dot. Okay, cd dot dot is the command. So this will actually go back one folder back. Let me show you. So now see if I execute the command. Now if I again check the project working directory, now you can see that I'm inside my root directory, that means this directory. Okay, LangChain project. Now I can easily access my data right now. Okay, this is the idea. So make sure you always check the path, project working directory. Okay, if you're working with, let's say, Jupyter notebook in a specific folder. Okay, this is the requirement. Now let me define the file path. File underscore path is equal to, so my file is present inside my data folder. Okay, data. And let's say as of now I want to load this hgd.pdf. So it should be SDG. Okay, sustainable development goal. This PDF I want to load. PDF. Okay, and to load it I'll be using PyPDF loader. Inside that I'm going to pass my file path. Okay, and it will give you loader object. Now I'm going to load the data. So I'll just write data is equal to loader dot load. That's it. Now see if I execute, it should load the data. Now if I show you the data, see, so the complete documents, so guys, you can see it has extracted all the data from the PDF itself, and it is having around 24 pages. You can see it has started from 0 till 23. That means 24 pages actually it is having this PDF. If I open this PDF, you'll see that 24 pages it is having, and all the page content it has extracted. And some of the places you can see page content is equal to empty, because in this page actually there is no content, that's why it's empty, and whatever actually documents I'm having, it has extracted, okay, one by one everything. Now if I want to show you the length, you can see 24 pages are available, okay, in the PDF. Now what I have to do, see, it's a separate page content now I'm having. Now I want to, let's say, store all the data in just one variable. So for this, what I will do, I'll just take a variable here. So let's say variable name is question underscore gen. You can give any variable name, it's up to you. It should be initially empty string. Now I'll just write a for loop. So for page in, let's say, data, let's say the complete data I'm having. So it will give me all the page one by one, and I just need to extract the content. So question gen plus and equal. I'll be just adding, okay, in this variable, okay, this is the idea. I'll just write page dot page underscore content. Okay, so it will give me all the content one by one, and it will save inside this question gen variable. Now let me show you. Now if I print my question gen, now see, all the data I have extracted, okay. See, now it is in one place only. This is the idea. Now see, this part actually have completed. That means whatever PDF I uploaded, I extracted the entire documents, okay. Now what I have to do, I have to do the chunking operation. That means I have to create a chunks for my large language model, because if I want to, let's say, generate the embeddings, before that I have to do the chunking operation. I already explained this part, I think you remember. So to perform the chunking, we'll be using one package. So it is available inside LangChain. So for LangChain.text splitter, so we'll be using one text splitter here called token text splitter, okay. So previously I think we used something called character text splitter, then recursive text splitter. I think you remember we use character, okay, character text splitter, okay, splitter. So with the help of that we can perform the chunking operation, I think you remember. Then we also have something called recursive okay, text splitter. So again, this is another method to perform the chunking operation. And now we'll be using something called token text splitter. Token text splitter. Now what is the difference between token text splitter and character and recursive? See, let's say this is my entire documents. So I think remember we used to perform something called chunk size. Okay, chunk size. Let's say 500. And there is another parameter called chunk underscore overlap. Let's say it's 100. Okay, now how it will create the chunks, I think remember, first of all it will start from the first and it will count 500 words. Let's say 500 words ends here. So this is our first chunks, okay. And to start the second chunk, first of all it will apply the chunk overlap. Let's say 100 word back actually it will go. So it will count 100 word. Let's say this is the 100 word start from here. So it will start the second chunks from here, and again it will count till 500 word. Let's say 500 word ends here, okay. So this is my second chunk, okay. So that's actually it will perform the chunking operation. Now you can see there is a chunk overlap you got. So this is called actually overlap, okay. This is called overlap, and with this overlap actually my model will understand after this first chunks, this chunks is coming, because you can see it is getting overlap now. This is the actually manual approach actually we can consider. This is the manual approach we can consider to get the context of my first chunks and second chunks, okay, and so on, like whatever chunks actually we are defining here. But this is actually what we do in the character text splitter or recursive text splitter. But what about token text splitter? See, token text splitter, what it will do, instead of using actually this manual approach, it will use one large language model. In case actually we'll be using something called GPT 3.5, okay. So this GPT 3.5 will decide, okay, how to create the chunk, how to perform the overlapping, and it will automatically remember, let's say after this first chunks, this second chunks is coming, after second chunks this third chunks is coming, after third chunks this fourth chunks is coming, okay. Your large language model will try to remember this part, okay. And this is like more powerful method than your previous one, whatever, let's say, method you used previously, because now LLM is like remembering everything, the context, okay. That's the idea here. So let's try to export this this token text splitter. So for this I'm going to open up my notebook. So I already imported. Now let me execute. Now see, this is the syntax to use the token text splitter. So I think you remember previously we didn't use any kinds of model name whenever we used to perform the, let's say, chunking operation. Now you can see I'm using the model name. I'm using GPT 3.5 Turbo. That means my model will try to decide, okay, how to remember the context. Now you can see this is the chunk size. Chunk size I'm expecting 10,000. Okay, 10,000 actually word would be considered as one chunks, and chunks overlap should be 200. Okay, as of now, let's say this is the things I'm just showing you, just to show you, okay, how it will work. It's just an experiment. Okay, I'm just showing you how it will try to create the chunk. Now let's define the splitter. Okay, this is my splitter. Now inside that I'm going to pass my entire documents. So you can see the entire questions and documents actually I'm passing to my splitter. Okay, splitter objects. You can see split text. Now it will give me chunk questions, and that means the chunking. Okay, it will give you the chunking result. Let me show you. So here is the chunk I got. See, this is the chunk I got. Now how many chunk it has written? For this you can use length function. You can check. See, it has only given me one chunk. Because why? The PDF, you can see this PDF is DG. So if you count all the words, it won't be actually 10,000 words. Okay, it won't be 10,000 words. It is less than 10,000 words. That's why here I've given chunk size is equal to 10,000. It is only considering one chunk the entire documents, because I told you if you count all the, let's say, word, okay, in this let's say PDF, it won't be 10,000. Okay, because it's a like huge size I have given here, just to show you, okay, how chunking will happen. Now let's perform our actual chunking. For this, what I have to do, I have to first of all convert this actually data to the document format, because you can see now it's a list format. Okay, if I show the type, okay, if I show you the type of this one chunk question, it's a list. Inside that, if I just extract the first element, it would be a string. See, it's a string, but I have to convert to the document representation. So for this, what I will do, I'll import one class from LangChain called docstore documents import documents. Okay, with the help of documents we can easily convert any kinds of string to document representation. Okay, now let me show you. See, now whatever, let's say, data you got, that means your this one chunk question gen. So I'm applying on for loop. That means it will give me all the, let's say, data one by one, and I'm converting to the documents, you can see. Okay, and I'm storing in this particular variable. Now if I execute, now see, I got the documents and it is format of documents right now. Okay, now if I show you the type of document question gen, it should be a LangChain code document base document documents. Okay, it's a now document format, because if I want to apply the splitter, so first of all you have to convert everything to a document. This is the recommended way. Okay, if you're also giving the, let's say, string directly, it's completely fine, but this is the recommended way. First of all, convert everything to the document format, then try to use the splitter, that means the chunking operation. Now I'll do the chunking again. See, again token text splitter. Again, I'm using GPT 3.5 Turbo model. Now I've given the chunk size is equal to 1000. That means 1000 word I want to consider as one chunks, and chunks overlap is equal to 100. Okay, now let me execute. Now let me give my documents. Now you can see document question gen. Okay, I'm passing it to my splitter. Okay, splitter object right now. Now it will give me the chunk. Now let me show you. Now see, I'll get multiple chunk here. So I got here 4 chunks. Okay, 4 chunks actually I got from the entire PDF. Now if I show you the length, see, 4 chunks I got. Fine, I think it is clear now. So guys, as you can see, we successfully created the chunks. Now the next thing what I have to do, first of all, I will generate the questions. Like whatever, let's say, chunk I have created, I will pass to my large language model and I will generate the questions. Okay, interview questions based on the prompt actually I'll be providing. I think you remember, we'll be passing one prompt to the large language model. Okay, so with the help of this prompt, actually, I'll tell my large language model, I need a interview questions. Okay, let's say the documents I have given, based on that, it should provide me some interview questions. That's what actually I need to perform. So for this, I don't need to convert these documents to the embedding representation, because as of now, we are only passing the, let's say, documents to my large language model. Large language model will give me the questions, but later on, whenever, let's say, I'll be doing the answer generation, okay, the complete answer generation, that time actually I need to pass the entire documents. Okay, and it will create the vector embeddings and it will store to the vector database. Okay, and vector database, I'll connect my large language model, and large language model will refer this entire information to give me the answer as well. Okay, this is the idea. So let's define my large language model right now. So here I already told you I'm going to use something called OpenAI. large language model, that means GPT 3.5. Okay, this model. And to use it, I can use this class actually chat OpenAI. You can also directly import OpenAI. It is completely fine. But we can also import like that. Okay, both way you can import. And if I am importing like that, so here I can also give my model name. That means which specific model I want to use, whether I want to use, let's say GPT-4 model, 3.5 model, you can use. So let me show you. So this is the code snippet. So chat OpenAI, inside that you can give the model name. Let's say I want to use GPT 3.5 turbo model, and this is the temperature parameter. You can also give max length parameter and so on. So temperature parameter is a creativity parameter. I already explained. Okay, what is the temperature parameter? Now let me define my LLM. Now here I already created one prompt, guys, prompt template. Let me show you. So this is the prompt I have created, guys. You can see you are an expert at creating question based on the coding material and documentation. See, whenever I designed this prompt, actually I was like generating coding related questions, and now I'm using any other documents. You can see that means the this one, sustainable development goal and statistics one. So if you're using statistics one, that time you need to give statistics material. If you're doing sustainable development goal, you have to give sustainable development goal here. That means whatever subject you are referring, you have to give the prompt with respect to that, because it's a changeable prompt. Is changeable. Okay, you have to change every time based on your requirement. Now your goal is to prepare a coder for a programmer for their exams and their coding test. You do this by asking the questions about the text below. That means whatever, let's say, data user will provide, that means these chunks. Okay, based on that it will create interview questions that will prepare for the coder, a programmer for their exam test. Okay, make sure not lose any important information. Okay, this is the prompt actually I have created, and I already told you like how we can design a efficient prompt. What is the art of, let's say, design a prompt? I already took on session on the prompt engineering. That session you can refer. Okay, so that's how always you have to prepare a good prompt. Whenever you are preparing good prompt, that means you will get a good response from the large language model. This is the idea. Now let me define the prompt. Now to use this prompt, I think I already taught you one concept called prompt template. You have to use something called prompt template from the LangChain. So let me show you. So this is the code snippet, prompt template. Okay, so here I'm passing the prompt template I've created, and this is the input variable is text. That means user will give this data. Okay, this is the input variable. I think it is clear. Now let me execute the prompt. Okay, now this is my template right now. We can do another actually very important, let's say, technique here. See, if you're not doing it, it's completely fine, it will work. But I was going through some of the research article, and I got to know people are using something called second layer verification. That means they are doing refined prompt template. So what is refined prompt template? Let me show you. I created one prompt template. See, this is the prompt template I again created. That means whatever questions actually your model will generate from the first prompt, you have to give those questions to the second prompt. That means it will refine that particular question. Let's say if there are some issue with the question, if let's say this question is irrelevant based on the topic you are asking, again this refine prompt template will try to refine, and again it will give you some new questions, okay, on top of it. So here you can see I've written the same prompt again, but one more additional information I have added. We have received some practical questions to certain context. That means it will give me some question. Okay, this question actually I have to give to my second prompt, and second prompt will try to check. We have the option to refine the existing questions or add new one only if necessary with some more context below. That means if some issue is there, if let's say it is irrelevant, that time what it will do, it will try to rectify that question. Okay, this is the idea. Give the new context, refine original questions in English. If context is not helpful, please provide the original questions. This is the idea. So this will actually refine prompt template. You are refining the questions here. That is the idea only. And this is like very powerful method, guys. If you are using, you will see that your result would be pretty good. If you're not using it, it's completely fine. No need to worry. But I'm showing you because see, we are creating an advanced application, and in advanced application, we have to take care. These are the part. Okay, this is super important. Let's also define this refine prompt template. Again, I'm going to use prompt template. Inside that, I'm going to pass the input variable. Now input variable is two. One is this existing answer. The existing answer I will get, and the text. That means again you have to give the entire text. That means the chunks. Okay. So these two input now you have to give. You can see text and existing answer, and it will give me the refined prompt template. Fine. Now I'll generate the questions. For this, I need to integrate my large language model as well as the prompt template. For this, I'm going to use one function from LangChain called load summarize chain. Okay. Previously, I think I showed you we can use chain. Okay, only chain we can use. Now there is another chain actually called load summarize chain, because inside LangChain you are getting different chains. Okay, we are using this particular chain, actually load summarize chain. Now we'll be creating my entire chain. See, this is the entire chain. First of all, you have to give the large language model. Okay, the LLM we have defined GPT 3.5. Then chain type is equal to refine, because we have prepared one refine prompt template. Okay, that's why it's a refine. Verbose true, that means it will show you the execution, all the, let's say, logs. Then here I'm giving the question prompt. First of all, the prompt I have defined at the very first. Okay, this is the question prompt. Okay, because it's a chain, it will execute after one after another. Okay, first of all it will execute, and whatever question actually I'll be getting, I'll pass to the refine prompt template. Okay, you can see refine prompt template. Okay, now this is going to be my chain right now. And now simply I'm going to pass the document question. That means this one I have to pass, this one. That means the entire document. Okay, this document I have to pass right now to my large language model, and it will give me the questions. Okay, it will give me the questions, and these questions I'm printing. Let me show you. See, it is generating and it is giving all the information because you have defined verbose is equal to true. Now see, these are the questions I got. I got 10 questions. Now if you want to get 100 questions, you can define here. You can define inside the prompt, I need 100 questions. Okay, you have to generate 100 questions. It will generate 100 questions. By default, it's generating 10 questions. Now if I want to show you, I will open in a text editor, see all the 10 questions I got here. But apart from that, I'm getting some more additional information. I don't need them. I only need the questions. You can see 1 to 10 questions it is giving me. What is the main goal of the sustainable development goals method? What are the some key achievements in the, see, that means if you read these questions, it's pretty good. Nah, as a human, if I tell you just prepare the question for me, I think you will be thinking in that way. Okay, this is the idea. That means my answer is pretty good, guys. And why I got the pretty good answer? Because I used the refined prompt template. Okay, so this is another powerful concept you can use. Okay, so now we'll be creating the next part. That means we'll be using the embedding model. We'll be generating the vector embedding, and we'll be storing to the vector database. Okay, because I also need to generate the answer right now. Fine. So this is what I have to perform. So let's do it. So for this, first of all, I have to define one embedding model. So here I'll be using OpenAI embedding model. So for this, you can import from the LangChain embeddings OpenAI. I need OpenAI embedding model. Okay, so let me initialize. So here I'm going to use OpenAI embedding model. So if you go to the OpenAI website and if you go to the model section, you'll see that OpenAI also provides lots of embedding model. Okay, so you can use any of them. Now I also need to initialize my vector database. So here I'm going to use FAIS vector database. I already told you. So it is available inside LangChain vector store FAIS. You can also use ChromaDB, Pinecone, Webbit. It's up to you. But I'm going to use the FAIS because I need to show you the FAIS as well. Okay, and FAIS is very like fast. I mean, than your ChromaDB. Okay, you'll see that it's like very fast, quite fast. Now let's initialize my vector store. See, that's how you have to initialize the vector store FAIS from documents, and you have to give the documents here, like which document you want to create the embedding. I think remember we created the chunks. These chunks, I think remember. Document answer gen. These chunks I have to pass, and I have to create the embedding. Okay, and I have to give the embedding model. This is the embedding model I'm passing. So this will give you the vector store, and it will save locally, guys. Okay, it will save locally. You won't be able to see that. Okay, it will save in memory actually. And if you want to see that, you can store in the cloud based. I mean, you can use the cloud vector DB that time. In the cloud, you can save. I think I showed you the Pinecone. There you can see the visualization of your vector. Okay, it's possible. Now let me again initialize my large language model. You can see again I'm using GPT 3.5 Turbo large language model to generate my answer, because you can see I told you na, the question I'm getting, I'll again pass to my large language model. Large language model will give me the answer. Okay, that's why I'm initializing my LLM again. Now previously I got some questions, I think remember. So this is the questions I got. Okay, these are the questions I got. If I show you beautifully, so what I can do, I can split with the help of /n. So it will give me line by line everything. Now this is the question list. See, so this 10 question I got. Now I have to generate the answer of this 10 question. Okay, with the help of large language model. Now for this, let's create a retrieval QA. Okay, question answer, let's say chain, because inside chain we are having different chains. I think I told you. Now I'm using retrieval QA chain. This chain I already used in my vector DB. I think you remember. Let's create it. Now let's initialize my QA chain. So here you have to give the large language model first of all. Now you have to give the chain type is equal to stub, because it's a QA chain. Okay. Now you have to give the retriever object. That means your vector store. That means you are connecting with your large language model right now. See, LLM, you are connecting with the vector store. Okay, for this you have to write this code, vector store as retriever. That's it. Now this is going to give you one chain. Now you can give the, let's say, question, and you can get the answer. For this I written a for loop here. See what I'm doing, whatever question list actually I'm having, I'm looping through it. That means I'm taking all the question one by one. Okay, you can see. Then I'm printing it. Then I'm generating the answer. You can see I'm calling this chain run question. That means I'm giving the question, it will give me the answer. This answer actually I'm also printing. After that, I'm opening a txt file. Inside that, I'm just saving it. Okay, inside that I'm just saving it. That's it. As of now, inside a txt file I'm saving it. Going forward, inside a CSV file I have to save it. Okay, this is the idea. Now let me execute. See, first of all, this is the first question, it is generating the answer. See, this is the answer. Okay, second question, it is generating the answer. Third question, answer. Fourth question, answer. So that's how it will generate for all the questions. Let me show you. See, beautifully it is generating. So we have created one amazing application, guys. Now we have to convert it the modular coding. There's the idea. Now see, all the answer I got. And if you read the answer, guys, if you open your text editor and if you read the answer, it's pretty good. It's pretty good. If you see that question and answer, it's pretty good. Now you can use as it is. As it is for any kinds of exam, any kinds of interview, you can prepare. It's amazing, right? Okay, so this is the entire actually, let's say, notebook experiment of our project. Now let's try to convert everything in a modular coding. Modular coding is, I just need to write everything in a function. That is the idea only. Okay, I'll refer the same notebook only. I'll copy paste the same code, but I'll write everything in a function. Okay, there is nothing new I'll be doing. So let's start the modular coding. So guys, now let's start the modular coding. But before that, let me show you this answer.txt. Now see, inside answer.txt, it has saved everything, all the question and answer. But again, it's not readable. So next time what I will do, I'll save everything in a CSV file. In one column, I will add the question. In another column, I'll add the answer. Okay, that would be more readable. So what I'll do, guys, as of now, let me close everything. So left hand side, I'm going to create a folder and I'm going to name it src. Okay, src, because this is going to be my source folder. Inside that, I'm going to write some helper related function. That means if you open up any kinds of, let's say, real-time implementation of any kinds of package or any kinds of project inside Python. Let's say if I open this one, Keras, GitHub, you will see that they have also created this kinds of folder structure. See, this is the Keras. Now Keras is also using this. See, it is having one root folder Keras. Inside that, they are also having the source src, and inside src they have created all the, let's say, utility related functionality. That means whatever functionality they need, let's say activation function, application, backend, callbacks, they're writing everything here and they're integrating in the endpoint. Okay, it is also having some endpoint. See, API gen, this is the endpoint, and they're importing it here. If you open it, any kinds of endpoint, they're importing it here. Okay, this is called actually modular approach. That means instead of writing everything in just one file, we have to create a separate file, separate function, and whenever I need it, I'll just call it. Okay, from that particular, let's say, helper function. This is the idea. So inside src, I'm going to create a file called __init __.py. Okay, this is the constructor file because this folder would be considered as my local package right now. See, this is the modular concept, guys. This modular concept I already explained in my Python session. Okay, so I think you know. So guys, this is our YouTube channel. So here, if you go to the playlist section, I already created complete Python course. So here I already explained about modular coding, everything. What is this constructor file? What is modular coding? How we can write any function in any other file, how we can import it in the endpoint, everything I have explained. Just try to go ahead and watch that one because modular concept is required here. Okay, I'm expecting you are already familiar with this kinds of Python concept. Fine. So you can also see the master OP actually playlist. So there also I have covered lots of advanced topic related Python. So that's why I'm creating this constructor file because this folder would be considered as my local package right now. Okay, and inside that I'm going to create a file called helper.py, and I'm going to create another file called prompt.py. Okay, prompt.py. So inside prompt.py, I'm going to mention my prompt. So let me show you. So the prompt actually I showed you in my Jupyter notebook. So here I'm going to just define. See, this is my prompt template, first prompt template, and this is my define prompt template. Nothing new, guys. I'm just copy pasting from my notebook only. See, the same prompt I just copy pasted because prompt is a changeable. Okay, it's a changeable, it's a static one, people can change anytime. So that's why I've written inside prompt let's say file. So user will open the prompt file and there actually they will change, so that they don't need to open the actual code implementation, and inside that they don't need to change. Okay, I don't need to hard code these are the value. That's why I kept this separate entity. I hope it is clear now. Now let me close it. Now inside helper.py, see, whatever code I have written so far, that means I loaded my documents, I performed the chunking operation, then I created the questions. Okay, these are the thing I'll be writing inside a function only. So inside helper, I created two function. First of all, you have to import all the required package you need. I think you remember these are the packages actually I need. I loaded in my notebook. Then I need to load my I need to load my OpenAI API key, and I have to set as environment variable. I think you know, got it right. Now the first function I have written called file processing. Same thing, guys. If I show you the same thing I'm performing here. First of all, I'm loading my documents. I'm adding all the, let's say, content inside one variable. I was performing this one. Chunking operation. First of all, I was doing with the help of 1000 token. Then next time I was doing with the help of, first of all, I was doing the 10,000. Okay, 10,000 chunk. That means one chunk I want to consider as 10,000. Then I was doing for the 1000. That means the same experiment I did here. Remember, same experiment. See, same experiment. I just written inside a function only. That's it. That is the difference only. This is called actually modular approach. You can also create a Python class, but as of now, it's a very, let's say, a small implementation. That's why Python class is not required. But if you see the actually very big implementation, any ML project or deep learning project, you will see that there I've written like lots of class. Let me show you. So inside US Visa, if I open the components, let's say data ingestion, you can see I've written a class that time. Okay, so class is required because you can see lots of function I have to handle. And whenever you are having lots of function, lots of method, that time you can write a class. But here I don't have actually lots of method. I only have 1 to 2 method. Okay, that's why I've just written directly a function, not a class. Okay, this is the idea. So that's how you have to design your own project, whether your project size is very huge or not. If it is huge, try to maintain the class, otherwise try to maintain the function. This is the difference only. So if you see any kinds of GenAI project, so most of the time actually we create, let's say, inference on top of large language model, we create a RAG application on top of large language model. Okay, that's why the code implementation is not big that much of. But whenever actually I'm creating any ML project, DL project, there actually we are training our custom model. That time actually lots of method we have to handle, very big code base we have to handle. Okay, that's how we need class concept. This is the idea. Now you can see, guys, I will get my object. Okay, object related my chunking. You can see it will give me document question gen. That means after performing the chunking, and document answer gen. Okay, both actually it will provide. So question gen is nothing but you can see I'm converting to the documents this question, whatever questions actually I was getting. So this is the document question gens. That means after converting to the documents, whatever documents I'm getting, this is my document question gen. And after doing the chunking, this is my document answer gen. So this question generation and this document I need for the answer generation. Okay, the same thing I perform in my notebook. I think remember. See, first of all, I was using document question gen just to generate the question. Okay, then I was using document answer gen just to generate my answer. Okay, I hope it is clear. So this function I have created, guys. Now the next function I have created, my LLM pipeline. That means I will be using my large language model. I'll be creating the vector embeddings. Okay, so everything will happen inside this function right now. LLM pipeline. First of all, I'm calling the file processing. That means this function, inside that whatever file user is giving, this file would be processed and it will give me document question and document answer gen. I'm creating my large language model, creating the prompt, both prompt actually. That means my prompt question as well as the refined prompt. Okay, both I'm creating. Then I'm first of all creating load summarize chain. I think remember load summarize chain I was creating. Okay, this one. So it will give me the question. It will give you the question, and I was creating the vector embedding after that. Vector embedding. Then I was creating the vector index. You can see vector index. Then I was creating the retrieval keyword at that time. Okay, it will generate you the answer. That means question answer. That means here you will get answer question generation chain and filtered question list. Okay, both actually will get. So these two function I prepared here. Now let me save. Now let me create the endpoint. So here what I will do, I'll create a file. I'll name it as app.py. Okay. Now this is going to be my endpoint. So inside that I'm going to call this function actually, this LLM pipeline. Because inside LLM pipeline, I'm calling my file preprocessing. That's why I don't need to call separately. So let me open it up. But before that, let me initialize my FastAPI related code. So if you go to the FastAPI documentation, guys, you will see this is the starter code. That means this is the demo code they will also give you. So these are the library you have to import one by one. Okay. Then you have to initialize the FastAPI. So how to initialize the FastAPI, guys? So that's how you can initialize the FastAPI. Okay. See, this is the code to initialize the FastAPI. Now here you have to create two folders, static and templates. Inside that you have to create the index.html file. So inside template folder you have to create a index.html file, because index.html file would be your home page. Okay, that means the user interface. So you need some HTML code. Let me show you. I already created. So guys, as you can see, I already created one template folder. Inside that I created a HTML file. Okay, now see, inside that I have written already HTML code. Okay, that means my front end part of my application. And how I created, again, I referred that Bootstrap website. I think you remember. I also used the Bootstrap website. If you don't know about HTML code, it's completely fine. You can skip this part. You can use, let's say, any other framework, let's say Streamlit on. And see, this HTML creation would be done by the front end developer. As of now, just to beautify this project, I created the HTML, okay, from my end. That's the idea. And there is another folder I created called static. Inside in static, I created two folders called docs and output. See, whatever documents user will upload, that PDF, it will save inside documents folder. And whatever output you will get from the, let's say, application, that means the question and answer in a CSV format, because you can see I've imported the CSV, it will save inside output folder. And from output folder, actually, I will get that particular, let's say, CSV output. Okay. And inside documents, it will store the PDF. That's the idea. Now, this is the FastAPI code, guys. FastAPI will handle each and everything. Now, I also need to import this one. That means my LLM pipeline. Let's import. So it is available inside, I'll call it from, let's say, src dot, let's say, helper import LLM pipeline. So it is inside helper. I need to import LLM pipeline because inside helper, I have this LLM pipeline. Okay. Now see, if I am importing like that from src helper import LLM pipeline, that means src is now considering my local package. And if I want to use src as my local package, what I have to do, I have to create one file called setup.py. Okay, setup.py. So this is the modular coding concept, guys. Again, inside setup.py, you have to write some setup related code. Let me show you. So this is the code, guys. Setup tool. First of all, give the project name, version, author name, author email, package, and install requires. That means this find package will try to find, okay, wherever this constructor file is available, this folder would be considered as my local package. Now you can see constructor file is only present inside src. That means src would be considered as my local package. Now see, if I show you pip list inside my environment, see, src is not mentioned. Src is not a package. Okay, see, src is not a package. But whenever I will install it, whenever I will install this setup, you will see that this src would be considered as my local package. That means there would be a package name called Generative AI project. You can give any name. I've given Generative AI project. Now let me save. And to install it, in the requirements, you have to add one more line called -e space dot. Okay. So this -e space dot will look for the setup.py and it will install this package. Okay, let me show you. Now if I again run, let's say pip install -r requirement.txt. See, this would be installed as my local package right now. Done. Okay, now see, some egg info file would be created. Okay, whenever this egg info file is created, that means this setup is successful. Now if I again open up my environment, that's the pip list. Now see, there is a package it has created, Generative AI project. Okay, now see, it is my local package right now. That means this src would be considered as my local package. Now I won't be getting any kinds of error right now if I'm importing like that. Okay, so this is called actually modular approach. I think you got it. So here, first of all, user will upload one PDF. For this, I have written a function with the help of FastAPI. So this is the function. So there is a route called upload. User will upload one, let's say, file, and this file would be saved inside my documents, inside statics documents. Okay, it will save. Now there is another function I will create called get CSV. That means the complete results. Okay, I want to save as a CSV file. So this function will help me to do that. That means the file actually I'll be receiving here. This file I'll give where in the LLM pipeline. And LLM pipeline, what it will do, it will pre-process. It will create the, let's say, prompt and everything. Then it will give me the that means chain, entire chain. Okay, and that chain actually I will utilize here. You can see. So you can see I'm getting the entire chain, and whatever question list actually I'm having. Okay, question list. I'll pass the question inside my chain and it will give me all the answer. And this answer actually I'll save inside my CSV file. You can see right row. Okay, CSV writer right row. And for this actually I'm using CSV package. You can see CSV package. Very simple code, guys. Only have written inside a function only. You just need to go through this code. You will able to understand. Okay. Then I need another function, guys, called chat. So this particular function, what it will do, it will load the output file. That means the CSV file. Okay, and it will show. It will return you. Okay, it will return you. That means you can also see the complete PDF, okay, in the UI. Let me show you how this application will look like. So now let me execute my FastAPI code. See, this is the FastAPI code. If you can run app, this is the local host and this is the port number 8080. Okay, now let me save and now let me execute. So I'll open up my terminal. So python app.py. Now see, it is running. Let's me give the allow permission. Now I'll go to my Google Chrome, and here I'll search for localhost 8080. See, this is the user interface, guys. Okay, now here you can upload a file. First of all, let's say I'll upload this file inside data. Let's say I will upload this SDG. First of all, this sustainable goal development, and here I'll generate the question and answer. Let's see. It is generating. This is the user interface we created, basic user interface. Now it's loading. And how this loading is happening, animation is happening, because I written everything inside HTML code. So guys, you can see I got the output. Now left hand side you can see it has rendered my entire PDF. Okay, the PDF I uploaded, and right hand side it has given me the CSV download. And now see, if I click here, it will download the CSV file. See, QA CSV. Now let's open the CSV. How I can open? Let's open it here. So I'll open it. See, this is the CSV. I don't have Excel right now, guys, in my system. That's why I've opened in a VS Code. You can see this is the question, this side, and that side actually I have the answer. You can open in a Excel viewer. You will see that it's a beautiful format I have just stored. Okay, so that's how actually things are happening. Okay, now I think you got it. Why we have written these are the function. So this function will help you to render your PDF documents, as well as it will give you the download option. Okay, to download this particular PDF. Now let's upload another PDF. Let's say I will upload this statistics one right now. Now let's generate again. So guys, as you can see, I got the results, and this is my PDF I uploaded, and let's download the QSSB as well. See, this is the correlation answer and question I got. Fine. So yes guys, this is the project. Actually, I hope you liked it, and this is like very interesting project, guys. If you develop it, you will feel like it's like very interesting. Going forward, we'll be also implementing lots of project, no need to worry. So in the next video, we'll be implementing another amazing project, very interesting project called Chatbot for any website. That means, let's say I think you saw website chatbot. If you go for any kinds of website nowadays, they're having their chatbot integration with that. Okay, so if you ask, let's say, some question related about the website, about their, let's say, product and service, it will able to give the answer. So that means they're replacing the human behind it. Previously they used to, let's say, use one human. They used to receive the chat, they used to give the reply, but nowadays they have added the chatbot there. Chatbot can handle all the answer. If you go to any of the website, you will see that. So we'll be implementing these kinds of application. That means the custom website chatbot, it will only work based on our website data, not any other, let's say, question and all. Fine. This is what actually we'll be implementing, and this is kinds of RAG based application we'll be creating. Okay, that means we are using our custom data. On top of that, we are adding our, let's say, like a large language model. Large language model will try to refer that data to provide you the answer. Fine. So in the next video, we'll be developing this project, guys. Until then, thank you so much for watching this video, and I will see you next time.